we are going to get started again with Debbie Aller. She's PhD and an extension associate at Cornell University. She's with the Cornell Soil Health Program, and she's going to be giving us a background and some more information about biochar and the application in New York State. Thank you.
Oh, thanks, Aaron, and thanks everyone for being here today and for giving me the opportunity to speak to you about a topic that I'm quite passionate about, and something an area I've been conducting research and doing extension in for a number of years at this point. And probably for a number of you, or at least online, I've given this presentation or some version of this presentation several times, so I apologize for those who have seen it before and it being repetitive, but have like giving 5-6 presentations the last couple of months, things haven't changed all that much. So I do have some new slides, and if you have questions during my presentation, please raise your hand if you're in the room, and I'd be happy for it to be more of a discussion like the other speakers have said. And yeah, if there's anything that's not clear, and then we can have a discussion at the end. But I think it is almost an hour I have to talk about biochar, so that would be a lot of time listening just to me. So as Aaron said, my name is Debbie Aller. I'm with I'm at Cornell University and with the New York Soil Health Program, or New York Soil Health Initiative, really.
Over here. Did it freeze up though? It froze up again.
So anyway, so Aaron had asked me to talk about biochar, not just from like an agricultural standpoint, which is the main area of focus that I work in with farmers and applying it on farmland, but also for some other uses. So I do have a few examples beyond just agricultural applications that I will, we're good now? That I will mention, but I will be brief on those, but I'd be happy if anyone has specific interests around biochar, specific questions about it, I'd be happy to follow up with information after today. So biochar, how many people have heard of it? Maybe have used it? Anyone? Heard of it. Okay, so very beginners on what it is, but for soil and water and SWCS folks, have farmers or anyone approached you about interest in it or questions around it at this point? No. Great, love it. An audience that's totally new to this, so I won't hopefully bore you completely. So biochar, what is it? It is a carbon-rich material. So essentially, it's a carbon backbone, and it's produced by pyrolysis. It's produced from any organic waste material, and it's converting something that would be a waste product to a higher value amendment for soil applications or environmental applications. And I'm hoping I will be able to provide you information and dispel any myths maybe you've heard about biochar, and allow you to be able to convey some more information, reliable information about what biochar is, how it can be used, how it cannot be used, what it is and what it isn't, to potentially producers or others that come to you with questions about biochar. So as I mentioned, it's produced through pyrolysis. Simply, it's kind of the burning, but in the absence of oxygen. So the difference between pyrolysis and incineration is this lack of oxygen. And through the pyrolysis process, we go from something that's very, let's say, highly digestible by microorganisms. It's very easy to break down, something like wood chips. And we put it through pyrolysis, and we get something that's very recalcitrant in the soil. So it's very resistant to breaking down. So there is, and I'm not going to talk about chemistry, but there's a change in the chemical structure of the lignin, cellulose, and hemicellulose that make up woody biomass, for example. And so through the pyrolysis process, we get 3 end products: gases or syngases, which can go back when we're thinking about industrial scale production, can go back to the electrical grid and serve for energy. We get a liquid or a tar kind of product that can be used in bio-based products, bio-based asphalts and things like that. Sorry, I'm standing in front of that. And then we get this third product, which is the solid biochar fraction. And until about a decade ago or so ago, biochar really and still is kind of the lower value co-product. So originally biochar was seen as a waste product of the pyrolysis process. And now it's really seen as a co-product because there's more value around it. So we essentially take any organic material, and in this example, there's a picture there of corn stover residue harvested from a field, and then we subject to pyrolysis and we get these three co-products. And so essentially we take that raw feedstock, and you can see the differences in the color there. It's pyrolysis is different temperatures, different residence times. There's variability within it, and I'm going to get to that in a few of my later slides. And so a lot of people think of biochar as charcoal. It looks like charcoal, but charcoal often is, we can think of it like for barbecues, something where it's a fuel source for something, and we don't want biochar to be a fuel source. We don't want to ignite it. We want it to be used as a soil amendment or other environmental applications. And so biochar itself, as I have up there, it's typically, this varies, but say generally between 50 to 90% carbon. So it is that carbon backbone. It is like a sponge, and it's incredibly porous material. So a lot of macropores, a lot of micropores, and these pore spaces are almost like homes for microorganisms. And as like a sponge, they retain water, or it retains water and nutrients. And this recalcitrant nature of it, so this long-term ability to stay in the soil and not degrade as rapidly as something like mulch or compost when it's applied to the soil. And I'm going to talk about all these things. And so there's numerous potential benefits of biochar. These do vary depending on the environment applied and the system it's implemented in. But there are really these potential long-lasting agronomic, environmental, and social benefits in some parts of the world. We don't see the same benefits from biochar in every system, but there are many, many opportunities for its use, especially within agricultural systems as strategic soil amendments. So benefits such as crop yield increases. These are often seen more in tropical systems, and we don't see them as much within temperate environments. Not to say that they don't exist at all, but there are more strategic applications, and I'm going to talk about this a bit later in my presentation. Obviously, significant impacts for soil health and soil carbon. When you're applying a very recalcitrant carbon material back to the soil, you're going to increase soil organic carbon. This has big incentives when we think of, let's say in New York State with the new CLCPA and all our carbon goals within the state and elsewhere, obviously. In thinking about Chad's talk earlier today around water quality and biochar acting like a sponge, it has actually been tested and successfully used within bioreactors as edge of fields because it can be combined with wood chips within bioreactors. Nutrient retention, all these pores within biochar for retaining water and nutrients, and I'm going to talk about that a little bit more. I mentioned the microbial activity. Remediation, it actually can suck up a lot with heavy metals and things like PFAS, which are an issue, and other let's say pesticides within the environment. Also waste management. You can produce biochar from dairy manure, for example, big source in New York State. Human health, it's more in developing countries around I'm not going to talk about that. But then climate mitigation and adaptation. So biochar is a net negative technology, especially at the industrial scale. Its production is an exothermic process. So once you get a pyrolyzer going or a bioreactor going, it self-drives itself, and then that long-term carbon storage in the soil makes it a carbon negative technology. And so there's a lot of companies who are interested in carbon credits now having programs around biochar applications. But it is not a silver bullet, even with all these potential benefits. It's just another tool for, well, it's getting cut off at the bottom, but it says it's another tool in the toolbox for producers. It's another option, something. It's not going to work in every situation, but if someone comes to you with questions about biochar, it is another opportunity, and there are benefits around its use. So kind of I want to step back slightly from that just introduction of what it is to how we got to where we are today with biochar. And it's a long history. It's an ancient technology that was really discovered in the Amazon basin in Brazil with these terra preta soils or dark earth soils. And so these are soils that are traditionally oxisol soils, are very weathered tropical soils that have low fertility, low productivity. And within those same environments, we see these darker oxisols. And essentially work has shown that these are oxisols with biochar, or essentially the organic remnants of like cooking stoves and other waste products that were left over hundreds of thousands of years on the soil surface that built up the organic matter and the fertility within these naturally low productivity soils. And we know there's similar soils across the world where indigenous communities had left the remnants of organic waste materials and built up the health of these soils over time. Actually, the Midwest US is a perfect example. About 50% or so of the soil within Iowa. And the reason Iowa soils are incredibly productive has to do with the natural history of prairie fires in that region and the build up of carbon and more recalcitrant forms of carbon that's staying in the soils. So biochar, probably 20 years ago, you would never have heard of it. And I obviously half the people in this room raise their hand that they've at least heard of it now. And I think some folks online have heard of it as well. But biochar, interest in biochar continues to grow very rapidly. You can see actually the start of this curve here is 2000, and now this was from a paper published in 2021. The reference is there, but you guys can't see it with the bar there. But in purple on this figure are the number of scientific publications around biochar. There are almost about 30,000 scientific publications in the past decade around biochar. So there's a lot more research and a lot more of a scientific understanding about its use and its limitations as well, and its benefits. And then the green bars on this figure are the number of US patents around biochar or biochar-based products. One example, it's not just the production of biochar, but also like there's a patent around using biochar in seed treatments. So that might be something Tim could be interested in looking at. But there's a lot of interest in it, and it continues to grow. This is just, I want to show a slide of just some of kind of the climate benefits and the soil carbon benefits and carbon sequestration benefits around biochar, in mentioning that it's a carbon negative technology and thinking how it can be used within a larger kind of farming plan or municipality plan around reducing carbon emissions and anthropogenic CO2, let's say. And also methane reduction. I do want to point that out. This figure is from some recent work actually done out in California in looking at biochar versus no biochar in reducing methane reductions from dairy farms. This was a recent paper there, and that by adding biochar to composted dairy manure, it can reduce the methane emissions coming from these systems. And there is work, and I'm going to talk about that, coming out of Cornell around incorporating or using dairy manure from New York State farms to produce biochar. I do want to mention just for this group, some biochar uses beyond agriculture, because I know folks work in a variety of environments, in water, wastewater treatment, cosmetics. It can be applied in various sectors. And the picture I have up here on the screen is biochar being put into building materials for homes and making homes like drywall material, substituting a certain fraction of drywall material with biochar and making homes carbon negative and being able to sequester carbon. A couple other applications beyond agriculture are for stormwater management. I thought this might be of interest to this group and thinking about water quality and runoff, thinking how biochar can be used in bioreactors, as I mentioned before, or in saturated buffer strips. It can be incorporated into green roof systems as well. So I pulled these just for the sake of the presentation off some fact sheets that we created at the United States Biochar Initiative, and also the Nebraska Forest Service working on putting these informational fact sheets out there about what biochar is, how it can be used in various applications. Right now, we're working on the fourth fact sheet of 7 on these topics. So if anyone has interest in a specific topic around biochar, we have it's using compost, which I'm going to say now, stormwater. There's one about to come out on manure, and one, I forget what the fourth is right now, but we will also be making them around specific crops and their applications. So I can send PDFs of these if you are interested in them. This is just how biochar can be used within compost production. It actually is known to speed up the composting process, and that's it's of interest to compost producers. It also helps with odor reduction and limiting pathogens within compost production and other sectors. And so this is just getting at what I was saying before around biochar being a recalcitrant material and incredibly stable once it's applied to soil and other environments, that if we look at kind of the degradation rate of uncharred organic material, let's say as an example, like wood chips over here compared to biochar, the amount of carbon that remains within that material over time is much greater for a biochar material because of the pyrolysis process. And this one just showing it compared to a growing tree. When a tree is growing, we're obviously continuing to build carbon, have carbon there, but once we've degraded, or let's say cut down and mulched a woody material, if we pyrolyze it into biochar, there's a much greater fraction of that carbon that remains over hundreds to thousands of years. I do want to preface that although the majority of the carbon stays within biochar, this is variable depending on the feedstocks it used. Thinking about a wood chip feedstock versus a dairy manure feedstock versus maybe rice hulls or oat hulls or corn stover residue. So it's the feedstock, and I'm kind of showing that on the left figure on this slide of the different feedstocks. And then it also has to do with that pyrolysis conditions or the production conditions. And not getting into the nitty gritty there, but researchers use the H to C, or the hydrogen to carbon ratio, or the oxygen to carbon ratio of biochar products as an indicator of its overall stability. So its ability to remain have a certain fraction of carbon remaining after hundreds to thousands of years. So this can be helpful in terms of thinking of planning or for carbon credits and things like that. So biochar production, this is often of interest to people, and why I want to bring it up is that biochar can be produced by you in your backyard. There's incredibly low-tech methods to producing biochar, and then all the way up to industrial scale production, where biochar is, we're maybe only getting 15 to 20% of the end product being biochar, and the production is really targeting the gases and oil production, because those currently are higher economic value. But a lot of farmers are producing it on their farms. I was just talking with someone before, say in vineyards, there's a lot of waste material from the prunings of vineyards, or in orchards as well. Can farmers produce biochar and apply that back to their land? So it is being produced on farms here in New York. There are other producers coming online as well. Some folks may have heard, for example, like Seneca Farms biochar, that's one local in the area. There are also producers in the Hudson Valley and on Long Island as well. Something that is, I think, of particular interest, I hear more and more, and this is something that's come out of, well, really, the U.S. Forest Service has had significant interest in biochar because of its ability to help with forest management and residue management in forests, but mobile pyrolysis unit. So this picture here, I believe that's maybe a char boss or something like that, but basically pyrolysis kilns that you can bring around to different farms or different areas where you may have a stockpile of organic material that could be pyrolyzed and then applied back within the same location. So I just want to point out that there are all these different methods of production and scales of production. It's produced in, maybe 5 pounds of biochar up to 50 tons a day of biochar. And within all this production, and as I mentioned with the slide before, that biochars are, because of the feedstocks and the production conditions, there's an incredible diversity in biochar products. So when we talk about biochar, it's not just one biochar, it's many biochars. And so the picture on the left there is the same feedstock with different production conditions. So this was a switchgrass feedstock, and looking at a slow, a fast, and a gasification char. So this has to do with the temperature at which it's produced and the residence time. It's actually at that highest heating temperature. And then also generally different feedstocks, different production conditions. You can just see in this image, different colors, different shapes and sizes, and these can be ground and obviously physically put into a different particle size, but just thinking out of the kiln, that's what it looks like. So because of this diversity with biochar, it leads to different impacts in the environment. And similar to the genetics by environment interaction, it's the same with biochar, and that soil, crop, biochar, management, and environment all play a role, and then the impacts it has, let's say on crop yields, for example, in this case. And also we know the properties of biochar change over time because it's organic. Even though the majority of it is recalcitrant, or a large fraction of it is, it still degrades over time by physical degradation, chemical, and biological. So these properties do change. And because of this variability and these differences, this is one reason that up until very recently, it has really limited its adoption, because we couldn't say this biochar in this environment's going to have this impact. We have a much better idea of that now, and I'm going to mention some decision support tools that have, or a decision support tool that has been developed that's going to help with making decisions around biochar applications within agricultural systems. One thing that's been important for the biochar industry as well is around this idea of certifications and standards, and giving basically telling consumers that biochar is a safe product for use. I think this is important in any industry, that having standards and knowing that a product meets a certain level of quality and it's going to have a let's say positive or it's going to be safe and have not be harmful within an application. So giving more certainty to customers and markets, this idea of quality and assurance around a product. So there is a international voluntary program around certifying biochars, and this is something for biochar producers to provide their customers with quality assurance that it's been tested, doesn't contain heavy metals, it doesn't contain contaminants or anything like that. Currently, there's no US program, but the US Biochar Initiative, we are working on developing one or thinking about it and realizing that this is critical for the advancement of the industry. So one thing that's really important, as with any product, I think, whether it be a fertilizer product or a pesticide, is why are we using it? Why do we need this? What is the problem we're trying to solve? So that's one of the first questions. If a farmer comes to me is like, I really am interested in biochar, I think it would be great for my soils, I need to improve soil health, I want to increase my crop yields. Well, what is the issue you're having on your farm? What are you trying to solve? Are you looking to improve water retention? Are you looking to build organic matter? Are you looking to enhance microbial activity? So these are things to think about, whether you're a producer, you work with producers. I think this is, there's a lot of potential, but if you use the right or use the wrong biochar and you, let's say, over apply it, you could have issues. One thing that's obviously important, and another thing that has limited the actual use of biochar has been its availability and cost. And this remains an issue today, but it is changing. The markets are changing. As more producers come online, the price is decreasing, and availability is increasing. The biochar markets and the ability to access biochar is much higher on the West Coast of the US, actually. And there are producers buying biochar from California or the Midwest and bringing it to the Northeast. Although there are a number of producers within the Northeast as well, it's far fewer than the West Coast. So these are just to give you some idea of prices for certain amounts of biochar, and really in the future, can this decrease and be more competitive with, say, the cost of compost or something like that? Because right now, actually, most of the cost around a biochar is around transportation. And also, when we think about it from a carbon perspective and a climate change perspective, we don't want to be transporting carbon around the country. So we're thinking about sourcing local and sourcing from a sustainably produced material, something where it's an organic, or sorry, where it's a waste product, like dead or dying trees that are being cut down. I know a popular feedstock now in New York State is ash trees, just because a lot of those have been cut down around the state. From a soil health standpoint, these are just an overall summary slide of the impacts of biochar on soil, and its ability to be a part of a management toolbox for producers, specifically when it comes to, say, soil moisture retention or increasing microbial activity, reducing soil density and alleviating compaction. So this is just a summary of some of the benefits there with biochar. I just put a little bit more here, not gonna repeat that. again, this is also just a summary slide. I realize it's very small for the folks in the room here, but this is a systematic review of over 26 meta-analysis in the literature. So about 10 years ago, as I mentioned, the science wasn't there. The industry around biochar started to take off, but we didn't have the scientific foundation to be able to provide recommendations. Now there are so many publications out there, and so many meta-analysis basically summarizing the overall impacts biochar has in hundreds of different environments and different soil types and things like that. And summarizing things like, let's say, impacts on crop yield. There, you can't see the bottom in the room here, but it's around a 10% on average across these thousands of studies, improvement in crop yield with biochar additions. And this is often, I do want to point out, which I'll mention in a bit, it's biochar plus compost, or biochar that has been inoculated. When we're talking about biochar itself, it's a relatively inert material and it needs to be charged before application. Because, as I said, it's like a sponge. So if you apply biochar after it's been freshly produced, it's going to suck up all those nutrients you have in your soil. So it needs to be somehow charged with compost or microbial inoculant, or your fertilizer blend, for example. A small amount of biochar can be added within that. So I am happy to share my slides after, but this is from a paper published last year, just kind of generalizing or overarching summary of its impacts on various agronomic parameters from thousands of studies. I do want to mention, because this for me, I've been very interested in soil moisture and soil physics in general, and the ability of biochar to impact soil water holding capacity or soil retention. And this was some work that was a modeling study actually that came out of Rice University in Texas, but is really consistent with many other studies out there. And this was done for the US as a whole, but the ability of biochar to improve soil water retention, soil water holding capacity. And I just wanted to show for New York State, hopefully the colors come through for you, but kind of where, as an example, biochar, if water retention on your fields, opposite of needing to drain your fields, right, that Chad was talking about this morning. But this is for sandier soils across the state. So in our heavier soils, maybe in the southern tier in Western New York, we don't want to retain more water in our soils, our muck soils, clayey soils, where there's very little infiltration, or it's very slow infiltration rate. Biochar maybe not be best in those areas, but in maybe parts of the Hudson Valley, Champlain Valley, Long Island, where we have sandier soils, and we're looking to keep that water on our fields, biochar could play a role in improving water retention within these environments. In terms of biochar application rates, this is always something farmers want to know. How much do I apply? And where do I apply it? How do I apply it? You know, the practical application side of its use. And that's a very hard or has been, let's say, a very difficult question to answer. I always struggle with it because it's not one size fits all with biochar. And their general, let's say, recommendations, we know there's a threshold. Well, definitely there's an economic threshold because it doesn't make sense economically. But if you apply excessive amounts of biochar, there have been detrimental effects, and we're talking studies showing 30 tons per acre application of biochar, which just would never happen. These were research studies, but basically to show, is there a maximum in terms of how much it should be applied? These that I'm showing in the slide here are much more realistic application rates. They can be applied as a one-time larger application rate, or could be smaller subsequent, like annual application rates of biochar to specific areas. And just emphasizing there that the biochar should be charged or inoculated with a fertilizer blend that a farmer would use or compost. And we're talking biochar, it's an amendment, so it's a small amount that's mixed into these other materials to manure, let's say. And particle size varies, and I'm going to mention that with in a few slides in terms of application amounts. This is again just giving some guidelines or some evidence around this inoculation of biochar, and also a new kind of field of research that's happening around biochar, and that's the creation of bio-based fertilizers. And kind of getting the benefits of both the quick release nutrients that come from manure or compost, and then that longer term recalcitrant material of biochar able to hold those nutrients and act like a slow release fertilizer over time. So getting both those quick release and longer release materials there. And this is actually an example from a New York farm that produced biochar, and what we mean by kind of inoculating or incorporating, using a small amount of biochar that you can see here that they produced from prunings, and incorporating that into a manure compost that they already had on their farm. So it's a small amount of material going in that can help help this farm with what waste material as well as nutrient and water retention within their fields. These are obviously dairy manure is a huge let's say storage and transportation of dairy manure in New York in general. We have an excess amount here, especially in this part of New York State. And so there's research ongoing by Johannes Lehmann at Cornell, a colleague, around producing biochar from dairy manure. And there are a lot of logistical issues here, but there are very promising results around its ability to produce a biochar that's odor and pathogen free, and it's competitive along with commercial fertilizers of similar fertilizing value. So really helping with a waste management problem and creating something that's valuable there. Mentioning some work that was done by a master's student over at the University of Albany, and others have seen me mention this before, just a small scale interviews around the adoption and use of biochar by farmers in New York State, and why farmers aren't using it. What are some of the barriers of adoption? So this, I'm just summarizing here some of what's been identified of why farmers aren't using it yet, why aren't others? A lot has been around the lack of awareness, the lack of understanding of knowing what it is, the costs around it, and not knowing how to use it, not knowing where to buy it, and things like that. And so this is just summarizing that there's a lot of interest in New York State around it, but there are barriers to adoption. But I do want to mention that farmers are using it in New York State. These have been largely a lot more within the higher value specialty cropping systems just because of the costs around biochar. But starting to see, I know Aaron and I have had conversations with some larger scale farmers around potential interest in biochar, and there's growing interest in trying it on their farms. Another thing that is helping encourage farmers to use biochar is there's a brand new conservation practice standard by the NRCS around its standard 808. Maybe seen it as was interim standard 808, and you may see it now as code 336, but it's soil carbon amendment. So it's basically offering, it is offering financial assistance to qualifying producers around applying compost and biochar and other carbon amendments. So if you're not aware of this, I would definitely encourage you to be aware of this. last week there was a great webinar put on by the United States Biochar Initiative and NRCS that laid out this entire practice about how producers can qualify for this practice, what it is, and the recording is available on the USBI YouTube channel now. It was a 2-day webinar series. So this is something producers need to work with their local NRCS office to see if they qualify for this. And this is for obviously working lands. I think part of it can go through the EQIP program as well. But this is really encouraging or incentivizing from a financial perspective to apply biochar, so lowering those economic barriers. I have a couple slides on how to apply biochar in different field applications, because this is something that producers have, they're like, okay, I have biochar, how do I use it with my existing equipment, or how do I apply it in a certain system? So these are just a couple examples. Broadcast and incorporation, a light tillage is certainly recommended, or incorporating biochar into the soil is really needed because it is a light material. If there's a heavy rain event and you have just applied biochar to the surface, it's likely to end up down at the bottom of your field. So just a couple examples here. These are in some other larger scale applications. Biochar can be, since it's put in with manure or compost or something like that, it can be spread using manure spreaders. It can be, if it's a pulverized biochar, it can be suspended within a liquid manure slurry and spread across fields like that. Also seen folks put it in with their granular fertilizer in no-till drills and drilling it into pasture systems. So there are many different ways it can be incorporated within existing production systems and with existing equipment. And I know Aaron had asked me to mention where to apply biochar, and this is very important. And there's a lot more scientific understanding and backing around this. If we think about our most productive areas of farm fields, maybe we don't need to apply biochar, but in areas where we may have more acidic soils, a low pH soils, we know biochars tend to, this does vary, there's a liming value around biochars, but typically biochars act like an agricultural lime. They tend to be on the more basic side of things. So if you have a low pH soil and you apply biochar, you're going to bring up that pH to a more neutral value. So we tend to see that in low pH soils, or soils where we have low organic matter, low cation exchange capacity, our ability to see a positive potential crop yield increase from applying biochar is greater. So this is what this figure shows. It's a paper from a colleague, Hamza Dukohaki, some work he did as a grad student. And this example is just perfect. It's the Central Valley of California. So I'm using it as an example for New York. You can think about it in any of the fields you work in, let's say, for example. But basically on the eastern side of the Central Valley, we tend to have more acidic soils, a lower soil organic matter, and a lower cation exchange capacity, versus on the western side, higher pH, higher soil organic matter levels, higher cation exchange capacity. So we can think of the western side of that, the Central Valley being higher quality soils and the eastern side being lower quality soils. Therefore, on the image all the way on the right, the red on the western side showing a lower potential for a positive yield increase from biochar applications, versus the green on the eastern side, where we see that a potential for biochar to have yield improvements is greater. So when we think about where we want to apply biochar, especially with the economics around it, we want to think about applying it to these poorer quality soils. And this is just summarizing what I said there, that the likelihood to have a positive yield response from biochar is in these poorer soils, sandier soils, low organic matter soils. And now taking this back home here to New York State, I was working with Hamza Dukahaki on this for New York State, and looking at areas where we could potentially see a positive yield increase from biochar. So we ran his same model, bringing in the Surgo data for New York State and looking at it statewide, where we would see potential yield impacts. And then actually, right as I was working on this, the USDA was taking all that data and the model that he had developed and putting it into their web soil survey tool. So our people utilize or familiar with the web soil survey tool. So now if you don't know, there's something called the dynamic soil properties response to biochar. And this is built into the web soil survey tool. So you can go into that, launch it with the green button like you normally would, select your area of interest. And under, I believe, the soil health tab, there is this new feature built within web soil survey. So you can go around for any of the fields of interest, and effectively see where biochar is likely to have a positive impact or a potential for increase in yield. So it ranks it based on excellent, good, fair, low, and unsuitable. So where you would not want to apply biochar, it color codes this kind of like you can see, darker green, yellow, there's red, orange. And so this is a really, really great start to actually being able to see where biochar would have an impact on a farm field that you may work with. I do want to say the model assumes, because I've been in contact with them about some of the assumptions behind this tool, that it's a corn stover plus manure feedstock that's being applied as a one-time application with minimum soil incorporation. So this model, this tool is going to evolve over time, I'm sure, but this is a great start moving forward. I think an excellent resource for planners and providers. The last thing I want to touch upon is another tool, and this is the decision support tool that started out as the Pacific Northwest Biochar Atlas, and now it's being expanded nationwide as the Biochar Atlas. And this was really spearheaded by a colleague of mine from, well, she's at the USDA, but Kristen Tripp, who has done Trippy, she has done some excellent work. She's with USDA ARS, but this is an online interactive decision support tool to basically, it pulls in once again the soils data, but it allows you, so you can plug in the soils data from your area of interest and then put in specific properties related to your biochar, and it will provide recommendations, partly, not necessarily recommendations, but guidance around how much biochar to apply. And it's based on the specific crop and soil and biochar parameters. So it feeds in all to these. I would have loved to have run through the tool with you guys online to show you how it works, but the links included there, you can go on. And part of it is, it currently is, it can be used across the US because it brings in soils data from there, but the biochars that you're able to input into the tool are only from Pacific Northwest biochar producers. And so that's what I was meaning. The work is expanding nationwide, that her and collaborators are collecting biochar information from producers around the country to then be able to put in the properties of those biochars. So say, eventually you'll be able to put the biochar properties of biochar produced in Western New York or Central New York into this and see how that local biochar is going to impact the soils right here in New York. So this is a really great tool that is expanding and really improving. And so just a few summary points. I'm not going to hone in on those, just you can read them. And I thank you for your time, and I'd be happy to answer any questions, or if people
Yeah, sorry. So thank you, Debbie. So I'm going to go ahead and actually address the online questions first because we're all kind of here and can mull around. And there were a few. So so just allow me that. And so the first question, and these are going to go back into your presentation a little bit.
Yeah, I see.
And then I will also post the CCA credit here in a moment. But so the first one was, what about the dead dying ash trees? Can these be used for biochar?
Yeah, I mentioned that, yes, and that's actually a significant source of biochar production for folks now because there's an abundance of that. So definitely they can be used.
Okay, the next one, what are the air quality implications for producing biochar? Are we creating another resource concern?
Yeah, and that's an excellent question, actually. And the answer is that no, I mean at larger scale production, like I mentioned, it's an exothermic process, and it's actually capturing and recycling the emissions back into driving the production of it. Also for producers in New York State, I know several that are trying to come online, but New York State also has pretty stringent air emission requirements through the New York State DEC, and producers, you have to get permitting. So it is quantifying air emissions, and it is a clean technology.
Okay, just a few more. How do the smaller kilns eliminate oxygen?
Yeah, that's a really good question. So there can be a small amount of oxygen in it. And with the smaller kilns, it's not as of a closed system as the larger scale production. So a small amount of oxygen is doable too. We're talking about open kind of campfires, and that would be incineration. So anywhere where you're capping it and limiting the oxygen to the production. So for some of the smaller kilns, these are specifically designed in the way you're actually if you follow the instructions on them, it is limiting greatly the oxygen.
And then I think you might have addressed this, but is one feedstock final stage preferred over another?
Final stage.
Yeah.
So I think
Debbie,
one of the
that was the slide you showed where they were burned at different temperatures, and maybe I can't remember the two parameters, and they looked like chunky or fine.
Oh yeah. Yeah, so I think, Janice, one of the big things with feedstock is it being from a sustainable waste material and also being a local source. So we're not talking about transporting. So for example, in Southeast Asia, biochar is being produced from rice hulls because that's a significant waste product. That's not something we have abundant here in New York. Whereas here we're thinking maybe woody biomass feedstock might make more sense, or manure-based feedstocks might make more sense. So it's really kind of specific to that area. Another example in Brazil, for example, they use a lot of sugarcane bagasse is a feedstock for biochar because that's a waste material in that area. So it's not necessarily preferred over another. If we think about it for like water filtration, that may be different.
Okay, just two more. Are there local sources of biochar, and what does it cost?
Yeah,
I knew you'd like that one.
Yeah, of course. So there are a few local sources of biochar. One thing that is an issue that came up when I was speaking in Western New York is the amount that we have available. In terms of absolute tonnage for farm use, it's not there yet. And that's why a lot of farmers are thinking about producing it themselves. There are producers in New York State. There are more I know purchasing equipment in the development stages of producing biochar. If I had to, I'm not, let's say I'm not advocating for them. I'm just saying a local producer is say Seneca Farms Biochar. They're in Odessa. And there's the Ithaca Institute in Shenandoah. They produce biochar as well. So there's some in the Hudson Valley. There are more coming online. Cost varies. The more you buy, the lower the cost, obviously, but cost I've seen ranging from $350 a ton up to $1,500, $2,000 a ton. So it varies widely. And that's why it's being used a lot more at the smaller specialty crop scale, or kind of home gardeners or green roof, or where the ROI is much greater.
And then I think you addressed this, but what is the lifespan of efficacy in soils?
Yeah, so that varies slightly, once again, as I mentioned, by the feedstock and by the production conditions, but it's on the hundreds of thousands of years time scale. So centennial time scale. So it's a very long lasting material. Once it applied to soil, it's not going to degrade like as rapidly as mulches or compost or things like that. So
Okay, that's it for the online questions. So if you are online, there's the CCA sheet. So I'll keep that up for a few minutes. We're going to break for lunch soon, but so if you're online, you can go ahead and well, we're still going to answer a few questions. We'll be back at about 1 o'clock for the online folks. Meanwhile, back live here in the room, what questions do you have for Debbie?
Have you heard of any like willow being used as a woody feedstock?
Yeah, I have.
So
Yeah.
question about willow being used.
Yeah, willow. Actually, I know there are researchers at SUNY ESF, because they have a large willow biomass study there that goes into the renewable plant there in Syracuse. But yes, definitely there's work in that area.
Tim actually, I think, had his hand up earlier. Did you? Nope, sorry. Okay, go ahead.
So with the longevity of the biochar in the soil, if you were to quote unquote misapply into a field that maybe didn't need it, can you potentially cause problems for like a long time?
In theory, yes. I mean, but really, that's if you're applying excessive amounts to it, or you apply a biochar, which very rarely, but if you use a feedstock that's contaminated, let's say with heavy metals or something, it's gonna stay there within that biochar material. But if you're only applying like a small amount or incorporating it with manure or compost or something like that, you're not going to have a negative impact. But yes, if you apply it, it's going to be there, and you're going to find it long after all of us. Yeah.
Dev, back in the 1980s, I actually got a graduate degree in waste management at ESF. And back then we were focusing on trying to accelerate the rate of decomposition to get to a similar endpoint, which you don't hear people talk about very much, but we were trying to create humus, right? So what we have with biochar here, to me, it seems that you've taken a shortcut to creating a type of humus, but you're being able to generate a material that's resistant to decay, because during the pyrolysis process, you're driving off the water, the nutrients, the micro minerals that make it attractive to the microorganisms that want to chew on this, right? So I think that one of the things we didn't focus on back in the 80s was because there was a real concern about the quality of the off gases from pyrolysis. but I've heard you say that you think it's a clean process. So how is the capture of those off gases factored into it being a clean process?
That's a great question. And I'm probably not the one to answer that because I'm not on the production side of it. Based on what I've read and seen, that the gases are captured. But in terms of the actual production, I know a lot of people that are in this area, but I'm not an engineer and I'm not on the production side of things. So I feel like I'm gonna stay shut with that, but I know people that can answer that from a production side of things, both here in New York or elsewhere. Either, yeah, I can follow up with you on that, but I'm not on that side to feel comfortable to answer that.
And then I have a second question. I was really intrigued by the statement you said that you have to charge your biochar to reduce its activity because it's gonna have all these binding sites to sequester whatever it can grab, because that's what it does. It's activated carbon, basically, is what you're creating. So the hazard of creating your own biochar without quote unquote charging it would seem to be something that a do-it-yourselfer would want to take into account, depending on what type of soils that they're dealing with. And lastly, one of the things that we focused on in trying to create quote unquote humus was, of course, to increase the carbon content of the soils, but it was also the buffering capacity of the soils, because back then we were all concerned with acid rain and acidification of soils. And I think that can be garnered from your presentation, but you didn't really focus on that potential of biochar to act as actually a buffer for acid precipitation or acid soils.
Yeah, those are excellent points, and I agree. And this was really an introductory presentation, so I was skimming a lot of different topics. You could, on one slide there, you could spend a whole hour talking about. So that's a great point. And it was emphasizing, especially from a agriculture perspective, this idea of charging the material, because when you're right in what you were saying before, that biochar it's a modern take on an ancient practice. So it was somehow trying to figure out, it started, okay, we have pyrolysis and we're targeting the gas production and the oil production, but now we have biochar. And what do we do with this? Is there value to it? So now with the biochar and the markets changing, there is economic value to biochar, and it's harnessing the potential that's there with this carbon product. And so, but as you mentioned, with pyrolysis, you're condensing the carbon backbone, and by charging all those surfaces, then you're not immediately soaking up all the nutrients that are already within the soil, and limiting that availability to the crop.
So what do you use to charge?
Compost teas, compost, manure, fertilizer blend.
Yeah, you're just giving those nutrients back to what you've driven off in the pyrolysis process.
Yeah,
Like you said, you're condensing that carbon backbone that makes it more resistant to decay, and it's going to stick around longer. But yeah, I understand that, but I think the charging is pretty important.
It's incredibly important.
Unless you want it to be really active in some instances.
I mean, biochar, like you mentioned, it's a bit different, but it's similar to active carbon in that that's used for like water filtration.
Right.
We have this material, it's the same thing. But biochar is more, it's the intended applications, the intended uses. But that inoculation part is so important, because 10 years ago when people were trying it, when researchers were testing it or farmers were using it, we saw negative yield because you would apply it as the raw biochar and
Extracting
it
it.
grabs all the nutrients and grabs everything from the soil. So now it's that the research has shown, and a lot of studies have shown, and obviously just on the ground, that if you mix 10 to 20% of your entire compost pile with biochar, you get the benefits of that long-term carbon that provides some slow release to those nutrients coming from the compost, but then you get that quick release and still your nutrient needs for your crop from that compost or from that manure or from that fertilizer.
But you don't get the same micro mineral boost as you would get with ash though, because you're driving all that off.
No, you don't want an ash. You don't want ash in your biochar. You want as low of an ash content within it.
Mhm. Well,
And-
it makes it easier to handle.
Yeah,
I'm gonna
but
jump in because
yeah,
we do
sorry.
wanna have one.
Yeah, sorry.
So, there were other questions, but I wanna have time for lunch.
Yeah.
And so we can
talk later.
talk later, you can email her, call her, she's very available. So, anyway, so thank you, Debbie.
Thank you, everyone.